Hi, welcome everyone for a collaborative session on Cassandra and HBase by Nagesh.
Yep.
Thanks for joining. Hello, Nagesh. Looking for you. How are you doing today?
I'm good. Thank you very much, Srini.
Excellent.
Thanks for the opportunity.
Oh, no, it's our privilege. Wonderful. So give me a couple of minutes. I think we have very good quorum. Hari, Harish, Arun, Hema, Narayan Rao, Sairam, Siva, Kiran. Sorry for the confusion. I think both Harun and me started the session, so there is a flip. I just took a long walk today. So usually after the session I walk, so it's a few minutes late. It's going to be great when we do always the collaborative sessions, because it is you who participate and deliver after good preparation. As you prepare, you all know you have some goal in the mind. Our body and mind works differently. You might have already experienced in your high school, colleges, when there are exams, your mind works very powerfully. On the day you have exam next day, even though it's not suggestible to read last minute, but you know, mind works very powerfully. So some people can't even learn those things in 2 weeks. So it is the same. A human mind and body reacts differently, because when you are presenting to someone, you want to make sure you present it good. For that, automatically you can overcome that threat with a good preparation. That is one side. There's a good preparation. Then when you are explaining to it, there is a human element to it. When you're writing an exam, even there is no big human element. You're writing answers. Whereas when you're explaining to someone, there is a human element in it. When there is a human element is involved.
Hey, Srini, you are not recording.
Oh, I think I am recording, Harun. You may be able to see. Can you see again? Harun? Can someone see? It's getting recorded?
Yes, Srini.
Yeah, it's okay. Thanks, Harun, for checking. So I want to encourage everyone to participate this. So Nagesh.
Sorry, Srini, I think my screen was the issue.
No, don't worry. So Nagesh is he collaborated with us in an amazing way, like Harun and like any of you. He went one step ahead, participating vigorously. He gave many seminars, more than 10 seminars in the last few years. And he's a very good friend of mine. He constantly reach me and discuss. Many times he asks very good questions, and he thinks he is learning from me, but I learned from him a lot. Just like any of you, you ask me, the discussion leads in a collaborative way. So we discuss with Hema, we discuss with Kiran, we discuss with you. Harun is always, anyway, I discuss, like Harish. So it is always in the discussion, apart from the knowledge, we also exchange the inspiration. Always look for whether you should inspire others or you should get inspired by them. If nothing is happening, that is a bad relation. Trust me, it's a bad collaboration. If you are inspiring them, either you should inspire them or they should inspire you. If it is both sides, it's a wonderful collaboration, trust me. So Nagesh is very knowledgeable. He comes with a great background of more than 18 plus years. He worked in ERPs, he worked in CRMs, he worked in big companies, and he always wanted to look something very interesting. So that is where he found these topics very interesting for him, and he see this is the way the whole world is going. So he started collaborating with me almost 3.5 years back. So the journey was amazing, and he always go extent for a friendly discussions, very knowledgeable. So he's a great guy to collaborate. I encourage everyone to connect with him, and he is ready to help with the time he has. Of course, he is busy in helping his son. That is definitely top priority for all of you. Self-help is the best help. You should serve your family first, definitely, later friends, then others. So he worked in big companies like Fidelity and other companies, and also now off late, he worked in a big assignment as a lead architect in Bank of America. He worked with different teams, Cloudera teams, and different enterprise teams. So he has a very in-depth knowledge both on system landscapes, from Unix level to programming to architecture to solutions. And he's more or less expert in NoSQL, because we had a great discussions. He went deep into it. Many times I focus very strong on basics, and I collaborate, because we have 24 hours. I cannot do everything. So that's where I collaborate with people like you, so that you guys can get deep into it. But everyone has their own strengths. I have very strong strengths to look into sources, to look into where the market is going, to look into what is important, what is crap, what should not be focused, all those things. That's where I will be very well helpful to you. And also how to simplify it for people, because a lot of people have a lot of knowledge, but when they start communicating to people, something goes wrong. They lose the connection of the people, and others get confused, and in the process they get demoted. So I touch wood, thank God. So God has helped me to have that understanding, mainly because of my own learning. When I was learning in early stages of IT, I came from mechanical engineering. It's a very strong subject. You need a lot of stamina to tackle these mechanical engineering subjects. So when we came to computers, even I don't know how to hold mouse. One of my friends taught me how to hold mouse. Say right click this, left click is this. So there is always learning. I have a lot of challenges to understand what's happening with this. But a lot of people confused me. A lot of people made it difficult. But there are some books, there are some videos, there are some people who made it so easy. So easy in the sense, still there are a lot of challenges, but it makes sense. It makes sense why operating systems are there, why our servers are there, why database layers are there, how they are connected with app servers, why app servers and web servers are different, why the concept of web servers came, why the concept of mashing has come, how the evolution of distributed computing from Corba and RMI, Java RMI has led into SOAP, and SOAP-based to REST-based. And more than that, after you collect all this data, how you analyze it in the data warehousing system. As the data is growing, companies wanted to not just analyze, and they want to do advanced analytics to survive, to proceed in the market. So to compete with others, to excel above others, to solve big problems. So that was the enterprise that is going on. Apart from the enterprise, a lot of internet companies like Google and Amazon and Microsoft, they are doing heavy research to make sure they do great business in the clouds and providing machine learning products, web services products, a lot of distributed systems. So these solutions are provided by them. On the third front, there are the huge researchers from the universities are heavily adding their knowledge into computing, merging computing, data, computer science, statistics, and psychology, neuroscience. All subjects are getting converged, trust me. So your cousins, your kids are going to be in these fields in a different way. This is like an ocean. Every river has to go to the ocean. Of course, some rivers dry up in Rajasthan and some other places. That is a different matter. So everything has to go to ocean. After going to ocean, there is no saying that I'll go somewhere. So this is like an ocean. It's a convergence. They call it as a what you call industrial revolution, industrial 4.0, 1.0, 2.0, 3.0, 4.0. 2.0 was IT. So we already talking about this is a computer science. So I want to make sure you don't miss this journey. And it is only a beginning. What you see is a tip off. So make it a lifestyle, just like movie actors focus on their career, sports people focus on their career, politicians focus on the career. You hold something, you need to spend time. You need to what you call, you need to focus continuously. You need to have dedication. This should be your thing. You may do something else for time pass, for relaxing, to help your family, that is matter. But your career is very, very important. Even people who have $10 billion also working hard for their career, because there is a satisfaction to it. There is a great meaning to do good things, to impact others. So see the meaning. Don't work just like just working for some salary, etc. Salary will come automatically. See the beauty, see the collaboration, stay with positive-minded people, stay with people who continuously learn, stay with people who can inspire you, or with whom you can get inspiration. Then that is a good karma. When you do good karma, automatically you get everything. So this is what exactly I want to highlight. Our Nagesh has a great background, doing good collaboration, always good intention to collaborate with others to help us. So looking forward for a greater collaboration with him. In the process, we all can develop our own strengths so that we can also help Nagesh. So with that, I want all of you, to welcome Nagesh to take over this, and Harun will be moderating this. Let's quickly check. Siva, how are you doing? Sairam Garu, how are you doing? Are you excited for this session? Narendra?
Doing good, Srini. Yeah, I'm all excited for it.
Excellent. Leela, how are you today? You want to say hi to everyone? Kiran, how are you doing today? You want to say hi to everyone?
Hi, Srini.
Hari, Kiran. Okay. Wonderful.
Hi, everyone.
Okay, excellent. Nagesh, hope I didn't put a lot of pressure on you. Be yourself as you always there. This is I know how much you love the NoSQL databases, Cassandra. You already gave a great session. So that is very helpful. Already Harun has put a good base, but I'm pretty sure go with scratch, discuss all your thoughts, take a break in between. Don't worry about the time, but make sure you give a break and continue. Nagesh, welcome.
Oh, yeah, sure. Thank you, Srini, for your kind words and a good discussion. So can I share my screen, or do you need
I'll
to
stop
give me...
and I will, Harun, I'll make you a host. I'm making you a host. So you're good in case I'm out here and there. He will take over. I think, Nagesh, you already know Hema, Kiran, you already know Leela.
Yeah, I know most of them.
Sairam is from Charlotte, and Siva, you know.
Oh, okay.
Oh man, you're not new to anyone. Narendra from India. Hari is a nice collaborator from Coimbatore. So he's a friend. All of these people are great to collaborate. Okay.
Sure. Thanks, Srini. Let me, Nagesh, I'll make you the host. You can share your screen.
Okay. Okay. Do you guys see my screen?
Yes, Nagesh.
Oh, yeah. Thank you. Okay. Let me start. Where is that? Okay. So is this better now? Okay, thank you guys for giving me the opportunity. Whatever, I mean, I gone back and forth with, I did Cassandra for some time and then HBase for my last project. So I thought if you know one HBase, I mean to say HBase columnar store, it's easy to understand Cassandra or vice versa. But HBase is more popular because wherever there is a Hadoop, HBase is preferred because they don't need to go for a different vendor or anything like that. So this is a practical reason some of the companies, they prefer HBase on Hadoop. And that's the reason I thought today, let me go through HBase. And I have the presentation of my past Cassandra I can share with you. If not, if you have any planning to do once in a month, if you want to get together, probably we can share that. Or I can share my presentation. You can go through that. If you have any questions, you can get back to me. Okay, with that said, I just want to give you, this is not going to be a practicals today because I didn't have time because my wife is leaving for India, so I didn't get time to install that VM and all that. I have the old VM, I don't think it will work. But I will share my concepts as in terms of this is like uncovering HBase. So I will discuss with you. If you have any questions, we can discuss. Later on, you can do your self practicals like you have done in Hive, I believe, right? You guys have done on Hive and RDBMS, right?
Yeah, we have done.
Anybody didn't work?
No, I think we have done Hive in our sessions. Everybody is aware of it. I've done that. Okay,
good. So you guys are familiar with the RDBMSs also, I think, because when you come with the background. So today, what I want to do is I will compare what is HBase and comparing the HBase to HBase. Why do we need HBase? When they choose, when do they choose HBase versus RDBMS? And after that, we will go through HBase data model. What exactly is that? And some of the HBase shell commands and HBase and Hive integration. This is what I've done in my past job also. So where we used HBase and Hive integration. Of course, Spark, you can integrate with HBase too. But in terms of business users, they prefer Hive because Hive on Hue, Hadoop user interface, where you have a browser based, where they can run Hive commands, then for them, it's easy to access underlying data in HBase rather than HDFS. So I just want to give you an idea. So this is what I'm going to discuss today. Okay, guys? Are you okay?
That sounds good, Nagesh.
Sounds good.
Anyway, we have this, your Cassandra YouTube. I'll share it to them. But there are some similarities so that they can connect.
Yeah.
Okay, thanks.
Yeah, they can connect to that. Yeah. Okay. Let's go to the. Okay. So when you have the shop, which Hadoop, when they have Hadoop, nowadays Hadoop means HDFS only. MapReduce is outdated. It's retired. Some people still use it, old programs, but the way it is organized is, see, you need to have a zookeeper. You need to HBase. It's a NoSQL database. It's a columnar NoSQL database, and it is on top of HDFS and HCatalog, and that is a MapReduce programs run on top of it. And also Pig and Hive. Of course, Pig is also outdated. Only Hive is there. This is the old way I'm showing you, just to have an idea. Here we are talking about the solution side, not the infrastructure or the internals of that. I don't want to cover that because we don't have time for that. I mean, we can go through that next. You have the region server, master, and all that. That is different. Physically, you don't need to worry about that. This is where, okay, people have Hadoop. Hadoop means SDFS, storage side, distributed storage, distributed processing. Nowadays, distributed processing is done by Spark instead of MapReduce. The only part it is left is storage. When you say Hadoop, it's HDFS, it's a storage. So basically, HDFS is fault tolerant, and you can transfer data between nodes during system failures. You know that replication and all that stuff. But HBase is a non-relational store. It's a when you say NoSQL database, we don't run. It doesn't support SQL directly on HBase. You have different commands like get, scan, put, and delete. There are. I mean, we can come to that command level. So you don't use normal SQL on HBase. So that is a difference. And when you look at the architecture side, I mean, you have a CAP theorem for the distributed systems. I mean, you guys need knowing the consistency, availability, and partition tolerance. I discussed that in the Cassandra very extensively on that. HBase also comes under CP type of CAP theorem. That means consistency and partition tolerance. It is similar to Cassandra. So when you look at the HDFS, it is more for a batch analytics. But whereas HBase is for a random reads and writes in real time, you can do that. Because you cannot do real-time analysis or on the HDFS. So industry said, we want on a Hadoop side, we want some NoSQL database. That's what the HBase came up. The both can do structured, semi-structured, unstructured data. When you say structured, as you know, relational type data, and semi-structured like email and whatever is that, unstructured, completely you can store images or whatever is that. So as you know, in HDFS lacks in-memory processing. That means MapReduce is an old one, but nowadays Spark has come with HDFS. You can do that. But HBase, it has got in-memory processing, so it drastically increases speed and read and write. Okay, and HDFS suited write once, read many times use cases. You write once, that is immutable, and you can read many times. But HBase is for a random write. That it's like throwing your ball. I mean, it doesn't care where you put it. You throw the ball, you catch it, wherever it goes, right? So it's a random write. And read also. You can read the data that is stored in HDFS. So basically, HBase is on top of HBase is on top of HDFS. So HBase allows dynamic changes, whereas HDFS doesn't allow changes at all. That is the difference. If you look at all this. Any questions on this?
No, Nagesh, we're good.
Okay. Okay. Let's divide the way I look at it is big data applications, not two, but I just said two here, because you have like a four. I mean, online applications, batch applications, streaming applications, and you have a mini batch applications, right? These are the four types in the big data world, if you look at that. If you look at the online applications, means user interactive applications. ATM, if you go to ATM, you draw the money and all that. These interactions are the user interactive, right? Even the credit card transactions, it's a user interactive. So these transactions nowadays, I mean, earlier it used to be not very large scale until the Facebook, LinkedIn came. This RDBMS are not able to handle. So with the big data in the Facebook and LinkedIn, you have trillions of transactions per minute. So that way, the online applications, it's called nowadays big data applications also. Earlier it used to be small applications, but now it's a big data. And you know the batch applications, it's like a background non-user interactions, background programs running it. Like it's generating, if you have a credit card transactions that is online, Amazon or anything like that. But if you look at the batch application, you are generating the bank statements, credit card bill generation. This is all batch application, right? So HBase doesn't want to use it should not call it a batch. You can call it as an online application. You can use it because you need to write very fast, like a trillion transactions. Let's go. I mean, just as it's a beginning, I just gave you. When you have a Hadoop to process batch processing, I mean, trillions of data. When it comes to online applications, RDBMS doesn't support that. So, as you guys know, RDBMS problems for OLTP. I mean, in a relational database like Oracle, you have a less transactional hits, right? Like for example, 100,000 transactions. It's not like a billion transactions per minute or anything like that. So RDBMS was useful, so very attractive those days. But now, when you increase the transaction rate, and this RDBMS is failing there. And the other problem is schema is fixed. These are two problems with RDBMS. Fixed. You cannot change. Once you have, for example, here on this, name is sex and city, you cannot add another column. You have to ask DBA to change. I mean, that's another, you have to go through the process. Every time you do that, runtime, you cannot change the structure. So this has become a big issue many times. I think you must have gone through that. In my past experience, I've seen businesses where say, I've changed this, but it takes time. Anything you go through, you have to go through all the procedures. So the problems with RDBMS was, it was good for less transaction hits, like 100,000 transactions per minute or whatever is that. But comes to billion or trillion transactions, it's not suitable. Okay, let me go through that. So here, for example, in the schema fixed example, what I'm giving is, if you have a structure like name, age, sex, and city, and people want to skip the age, but somebody wants to give sex only and city only. Somebody wants, for example, qualification or email. You cannot do that when you have the fixed. So you have to go through the changes. So this is become a big pain for if multiple applications accessing your table, it will be very headache for the business as well as the developer, everybody. So that's the reason NoSQL's evolved. They said, okay, let me solve this less transaction hits, high loads of transaction hits, because it can handle trillions of transactions. Like for example, when you look at the Facebook, LinkedIn, I mean, the way they have data is very huge. So how is that possible in NoSQL? Because of the cluster. Of course, even Oracle has a cluster. They go with a 2 to 6 nodes maximum. But in case of Hadoop or anything, or NoSQL databases, you go to 1,000. There is no limit for that. And even MySQL, there was a limit for 180 nodes, and SQLs were 2 to 6 nodes. And people used to do OLAP for the Teradata and Netezza. So if you have a trillion data, then you can use OLAP, but that purpose is different from the OLTP, online transaction processing. Any questions here? I just want to make sure I'm not connecting you. That means your guys are okay. Okay. The first advantage is high load transaction hits. Second one is a faster random access. So when you say random access, there are three types. One is random, sequential, dynamic. If I give the key, you get the one row from the billions of transactions. That is randomly you're asking the question. If you say sequential, it's like in a batch. You go through sequentially each one to get your desired record. Sometimes you may say the range, dynamic, that is, first you go random, then you go for a sequential. For example, 500 to 600 keys. So what you do is you pick up the random first 500 the key, and from there you go to the up to 600. So these are the random access types. So NoSQL is good for random access, but of course RDBMS also supported random access, but there are some issues with that because RDBMS uses binary tree, B tree they used to call, because you used to create table, and after that you create index page that gets whenever you start database that gets into the buffer pool, this binary tree, and if that binary tree is huge, like trillions of transactions, I don't think RDBMS in this case can run any binary tree searches. So that's the reason NoSQL, of course, uses binary tree. Some of the MongoDB and all still use binary tree algorithm for the random access. But there are people using random trial algorithm. This you must Srini extensively, I think, discussed the random forest trial algorithm in the machine learning. People are using that also in this. That's how they could achieve the faster access. The third point I want to say, NoSQL, it's a flexible schema, or you call it as a dynamic schema or schemaless. In the RDBMS, schema is fixed. You cannot change that structure. Whereas in NoSQL, you can have flexible schema. Only if you have like somebody can give the, one user can give their name, age, city. The other user can say, I want name, age, and email, phone number. The other user can say, a name and age and sex and other qualification, whatever is that. So each user can have a different attributes. User to user, different attributes can be specified. That is called a flexible schema. I mean, we'll come to that more in detail, but I'm giving you the high level. I mean, what is the use of this flexible schema? Okay, RDBMS was 30 years, it was successful. It was using schema fixed, everything went well. But nowadays, if you look at one example, Amazon, I think it's a 30 or 25 million products are there in this company. And in this product, you have all the products are in 600 verticals. Like, for example, toys and electronics and different categories. You have that. Verticals means here. So this 30 million products are types of 600 verticals. And if you have a one product table in RDBMS, you cannot have all this different type of attributes for each product. Otherwise, when you design that, at least you have to say it, sorry. At least you need to have 600 tables you have to create in RDBMS world. But whereas in NoSQL, one table is enough because of flexibility. So you're not doing any joining or anything like that. Based on each product, you have a different structure. That is the beauty of NoSQL. I mean, make sense here, or do you have any questions here?
Yeah, sure, Nagesh. So when you're talking about the structure, right, NoSQL, where we can have different schema for based on each record, how is it actually stored, or how is it defined? Because in our DBMS world, you define the schema when you create the table or the structure, right? So when you create, how do you create the same, create the structure, and how does it handle when you have new columns or when you don't have some columns storage in
Yeah,
HBase?
yeah. I mean, yeah, that we are getting into the example. Then
Okay.
I will come back and ask this question. It will explain you. That's a good, actually.
Yeah.
I'm just giving you, I'm making a statement saying that this is useful here. RDBMS, you have a fixed structure. NoSQL, we can have all this. Example is Amazon, if you look at that. Let's, I mean, apart from that, any other questions?
No, but when you said products of Amazon, right? I think I missed that. But products will, all the products will have the same kind of attributes, right? I mean, they might not have values, but all the products will have same, say, color, price, tag, brand.
No. I mean, if you look at like book or a TV, the book attributes are different from the TV attributes, right?
Okay. Yeah, got it. So yeah, book will have number of pages and all that kind of, and some
Number of pages, there's index for the TV. There's no index for that. TV is totally different. So each product has its own attributes. So you in RDBMS world, when you design that, what do you do usually? You say this should be a separate table, book should be a separate table, TV should be a separate table.
Yeah, yeah. In general, how you design is you design with product type, and then attributes. It'll be like a comprehensive list of all the attributes included, both for book and TV, and for every product. If you go to RDBMS, right? Something like
Yeah, I mean, usually they don't do, it's a more of normalized form, not a denormalized way. So when you say normalized, you don't repeat it. The value should be atomic, right? So you cannot repeat it. The data would not be there. Normalized form. Excuse me. So in the it's a normal RDBMS world. We'll make it as a different product, different table altogether. Book is a different table. TV is a different table. And let's say fruits or whatever is there. I don't know, even Amazon nowadays, they're selling the pickles. Excuse me. So you name it, they're selling everything. So for that, if you look at that, if you go by RDBMS way, people have to spend, days, months, or whatever is that for each one. So which is not easy. So with NoSQL, this is possible. We'll go through that why. Excuse me. When you have to look at a different way, I'm giving you Cassandra, there was the way we looked at it is different, but here I'm making a look in the OLTP side, how you can use HBase. Okay, I mean, that is, I just compared with the big data applications. I didn't say NoSQL, why we are taking HBase only, what is the HBase role? So if you look at that, there are many types of products, NoSQL, like 150 or 100, 200 or whatever it is that. But they come under 4 categories. One is the key value store. Key value store is like, you must have heard the map collection where you have a key value pair. That's what you do then. that is the database itself will have key and value. So for example, React and Redis and Yahoo, Peanut, these are the key value based key stores. So the access is needed. Once you pass a key, the value will be fetched. For example, if you look at Gmail, when you want to give the username sign in, you give the username password. That is the key value, right? That is one way to look at it. There is another one, document store, MongoDB, CouchDB. These are when you store documents as a documents, your data, like for example, your resumes or whatever is that, you can store in MongoDB, let's say. You don't need to create limited structure or anything like RDBMS. You can use this. But for example, you want to store column store. Column store is like HBase or Cassandra. HBase is for Hadoop world. Cassandra is for open systems. Here, the columns are stored as rows. Unlike in RDBMS, you can see set of columns are stored as row, right? But whereas here, columns are stored as rows. We'll come to that a little bit more. And when you want to use Cassandra, it should be an open system. You don't need Hadoop or anything. People, some of the companies there, I mean, I've seen they're using Cassandra itself without Hadoop. The other one is a graph store. You must have seen Spark graphics, that API. Similar to that, but there is a database, NoSQL database, Neo4j, that is the popular. So when do you use this? When you want to have a record-to-record connections, like for example, Facebook user connections, logistics, when you have that, the product is called Neo4j. That's what this is 4 types of NoSQL types. But I mean, each one has got its own purpose. You cannot use one for other. So user rate and password, let's say that example, Gmail, if you want to use, you can use React or Redis. And if you want to do search in the column store, faster random access, use HBase. I mean, I'm just giving you high level, I'm uncovering, but I'm not going deep into that. Let's say you have a connections you want to store, you can store it in Neo4j. So this is basically a NoSQL types and the purpose of each variety. So if you are moving from RDBMS to NoSQL, one NoSQL type store does not work for you. You have to look what is your purpose. So based on that, you have to move. If you have record-to-record connections, then you have to use Neo4j. If you're using random access OLTP system where you want to store faster, like throwing a ball, then you can use columnar store. You don't want any structure or anything, but you want to use documents kind of thing. You can use MongoDB or CouchDB. But you want to have key value like a Facebook. You sign in seconds you will get it. That's a key value store, React or Redis, whatever is there. So each one you store it differently. Each one has got its own purpose. Our idea is HBase only. I don't want to go deep in other things. So let's go further. I mean, I just want to touch before go to HBase, key value stores. Like for example, here the storage object is map collection, key value pair, right? Let's say the algorithm they're using is random trailer. The advantage is fast random access, like React or Redis or Peanut or whatever is that. So just I want to go through this before I go to HBase, so it will be easy for you to understand. So when you have RDBMS, when you create a table, what do? You create a structure like employee table. Let's take an example employee table, where you got a name, ID, salary. Let's say. And when you insert the data into table, what happens is it is stored under the table space. That is the logical name for the example Oracle. So table space is nothing but in the OS level, it's a file, right? File means there are blocks. It can be 4K blocks or 8K blocks or whatever it is, that we don't care. So in RDBMS, you are storing data in a table, and it's underlying table space and underlying one file, let's say that. But if you partition the table space, there will be multiple files, right? If you have a partition based on the date or city, let's say you partition based on city and employee table location, then what happens? If you have, let's say, Hyderabad, Delhi, and let's call Bangalore. If these three files are stored, their data is partitioned into that. So to avoid, I'm just giving you the background. It will be easy to follow through that. So when you start the database, what happens is there is a concept called buffer pools. You must understand, known that will contain index pages for all the tables. Let's say you have in a database, you have 4 tables and 4 index pages, index table spaces, basically, what I meant. So they will be in the buffer pool. That is like a virtual, where it takes from the hard disk as well as RAM. So what is the use of index object? It doesn't allow duplicates, but also allows for random access using a B-tree algorithm. You guys know B-tree, how it works, right? It's like a binary search. Recently, I taught my son about the binary search in Java. You take the minimum value and the maximum value. You take the mid value, compare the mid value. Based on that, you take the left set or right set. And again, based on the value, you will be dividing that set until you get the 2 key. Binary means only 2 values will be there, the maximum. So it is easy for you to search in those 2 values. You don't need to search entire. If you say you have a 10 values array in the index, then you're not going to go through sequentially. What do? You take the minimum and maximum. Based on that, with the 2 or 3 iterations, you can get to the value whether it exists or not, right? Any questions in the binary tree, or are you? You're good, right?
Yes, Manish.
Okay. So, but this binary tree searching in RDBMS world, it worked fine. But once it crossed, billions and trillions of records need to be searched. This index space has become a pain because you can't start the database also. Because if you have index space like a trillions of records, you need a lot of RAM. Virtual buffer pool should be too big. So this has caused a problem. And the industry said, okay, let's move to the random trial algorithm, not the mandatory, but still some B-tree algorithm is used in NoSQL because the index pages are distributed across the machines. It's not on the one machine. So that way you can use the buffer pool for that. It's not like a RDBMS. When you start, you have to have all of them. So this is the way the binary tree random trial algorithm for the random fast random access. That is the advantage of the storing in the key value pair. This is the basis for the HBase. I will just go through that. Because I could have put some figures, but I didn't have time, so I just put my words. Forgive me for that. But if you have a more pictorial representation, I can do it later on. But this is a okay. And this is a little bit dry, but I try to do whatever I can do. When you talk about the column store, you have the Cassandra. The data model for this map of map. So first map is key value. Key 1, map 2, first map. And the next one is key 2, map 3. And the next is this map will have key as well as value. Finally is a value. Is that a little bit confusing to you? This is a data model. I just declared that. I can go ahead.
Example, Nagesh?
I'm sorry?
Can we go with any example?
Yeah. Let me go through that. Okay. Bear with me for that. I mean, just take it for me. Later I'll come to that. If I don't come, just remind me. Because you need to understand certain things before going to that.
Okay.
I mean, you know the map, right? Map is nothing but a key value pair. Pair means key 1, comma, value 1. Key 1, key 2, comma, value 2. Like that, you'll have these. That's the data collection, right?
Yeah.
So the value in that would be another map. That's what I'm saying. It's a nested of map and map and map. 3. I'll come to the Y3. I'll come to that, but just keep this in mind.
Okay.
Columns stored as rows. So in you say the set of 10 columns you store as a 1 row and another the row 2 and like that, right? But with this in the column, all those 10 rows. First row in RDBMS, if you have a 10 columns, 1 row, then in the columnar store in the HBase, it becomes the 10 row. I'll to that example, a little bit dry. Just I'm giving you the idea here. And each column is associated with one. Is you have the table in the HBase world and column family. Each column family will have one column or more than one. There will be each column family is associated with one row key, and in one table column families. Let me come out of this and show you. So table will have multiple column families. Column example is well, employee department table, and if you have personal details, that is the personal details. It's the record types. Column family is a record type. Table is nothing but a database. The RDBM in HBase is equivalent to database in RDBM. Mind, because there is no database concept in HBase. When you say create, you say create table only. You don't say create database at all. So table multiple families. That means multiple record types. Is it working for you or no? Yeah. or record or row, whatever you call. I mean, this is what you need to remember. Database in RDBMS, for example, Oracle or MySQL or whatever is that. When you say database, it's equivalent in HBase is table. Table in the RDBMS is equivalent to columns family. Excuse me. Row in RDBMS is nothing but equivalent to column. Are you with me so far? This is a nomenclature. You need to be clear on this.
Yeah.
Okay. When I say it, rows means rows. Each row in RDBMS, when you convert to the HBase, it will be stored as a one column. I mean, taking if it row as a 10 columns, then becomes a 10 columns here. One row becomes 10 columns. Table is nothing but a columns family. Column family consists of a number of columns. Table contains multiple column families. Database contains multiple tables. But there is an extra one. In HBase, the concept of row key is associated with the column family. Column family is with the one row key. So one row key can have a multiple column families associated. I'll go to the examples. I mean, this is all theory. I'm just giving you a heads up. So we'll go to practicals. I mean, since I don't do online interactively, but I'll show you in my next slides.
Column family is like attribute, right?
Right. Attribute. Okay. Are you good with it so far? I mean, internally, you have to keep in mind data model is internally. I mean, you don't need to worry about that, but internally, when it does scan and all that, it does this based on this map collection. Nested map, basically. Map of map of map. Why that 3? We'll come to that very soon. Stable, columns family, column. If you remember this, I mean, there are other time variation, I mean, versioning and time to live and all that. You don't need to worry much about that. This is what you need to know when you design a table in HBase. Those are default. The other attributes we don't need to worry. So the other thing I want to mention here is discuss each column family can have multiple columns. This will categorize tables information, record information. So in the relational database, the focus and effort is around describing, you heard the term entity, right? And interaction with other entities. So what we do, once you create the entities and an interaction with other entities, you design the queries and indexes after creating tables in the relational world. But with HBase, first you design the query first. So there is no schema design in sense, you may have some create a table, column families, but you can dynamically create those columns. I'll come to that. But you need to know query first, and then you think of tables later. So all possible queries should be done first, and the schema model designed accordingly. This is a very, very important concept, whether you go to the Cassandra or HBase. This is what you need to keep in mind. Okay, let's come to the, what I'll take is I'll take how we design in the RDBMS world. How do you convert that to the HBase world? We'll see that. In the RDBMS, when you say, for example, take simple example like employee and department table. This is the world you are trying to create the tables. What do? Okay, you have to think about the columns, attributes, okay, which is the ID, name, salary, sex, ID number, department number. After that, you have a department number. You're creating department number, department name, location, and all is another table, right? You create normalized way, normalized data model. So once you create the identify the attributes, you'll group them to the employee table, other is to department. You will identify what is the primary key. So based on that, you can have a random access, right? And you'll find a foreign key. That means you have some primary key here. So when you have a foreign key, you need to find who is the parent. This is the parent, department number. Okay, this is the parent, this is the child. And this is your design in RDBMS. So what do you do? If you want to get the data for Kathy, what do? You select, you want to know location of the Kathy, the employee. What do you do in RDBMS? Select location from employee, L, join department R, joining the department number, the primary key, with this, right? With the foreign key here. And you give them what is the ID for this, 103. So then that way you would know the location of the Kathy. This is how you get the data access pattern in the RDBMS world. You create two tables, normalized, and you identified which one is a primary key and foreign key, and then you did this. This is a RDBMS world. Okay. In the, let's say you want to do same thing in HBase. So what is the logical model? We have to identify the first, this is a map, right? Key and cell, key and value, whatever you call. Let's call this logical model employee info. So what we do, we have the two tables here, employees and department. So if you want to store this in HBase, what do? You take the employee as a column family, department as a column family, and the e-info is the table. Whereas here in RDBMS, this is some default database or some name employee database. Within that, you have an employee table and as well as department table. So when you're converting it into relational, HBase, you're first identifying what are the column families there. So E is a, let's assume E is a one family and a D is one family. And the first thing you need to identify the key. Which one is the key? So to identify the key, you can take a department number. What happens is it gets overwritten. You have like a duplicate rows, right? The latest one gets precedence. Why? I will tell you later. So that is not a unique key. So the unique key you should take it from a child table. This is the parent table, department. An employee is a child table, right? In the child table, what is the unique key? This is a ID. So ID becomes your row key. Row key is a key, first key. Are you with me so far?
Oh, yes.
You're okay, right? So we identified the go ahead, please. Any question? no questions, I can go ahead. I'll go slow here. So we identified the row key, which is a, we have a row, how many keys we have? 101, 102, 103, right? Let's take only one key. One key, what we have, the data, name, salary, sex, department number. And here, department number, you have the 11, marketing, Hyderabad. Let's take only one. So when you say, how do you store in the database? I mean, in the HBase is like a, this is a table. E-info is a table. And it is got a, when we created, we said, we have two column families, E and D. That's what we said. That means you don't need to join, unlike in, sorry. Here, what if you want the information based on, if you want to know the location, you have to join this table. If you go to this HBase, you don't need to do join because you are saying this row key, this table contains two column families. So it knows, okay, I have to get the information from this based on the key. The key is this. I mean, maybe I should copy that. Sorry. Maybe I can do here. Forgive me that it's not a very elegant way, but I'm trying to make you understand. So it's a key one map to, right? So what we're doing is key is 101. For 101, this is a family. E is a column family. And the name is a column. And the value is Amar. So if you look at like this, for each column, I'm storing as a key value, key value, key value, key value. That's the reason it's a key one map to key pay. This is like a map, but I'll come to this nested one. So if you have a one row in RDBMS, if you look at here, this is called a row, right? 101 Amar, 10,000 M11. Here I'm storing like this. For one column family, I'm storing 101 E column. I mean, that's how you separate the key and name. And the value is equal to Amar. The second one is 101 E column salary 10,000. 101 E column sex is equal to M. 101 E family. I mean, sorry, it's a typo. D number is 11. 101. This is separate column family. D number 11. 01 D 101 D location Hyderabad. So what we did is we mapped successfully to the RDBMS word for one row. If you need a second one, you have to do the same thing. 102, 103. So how it is organized internally, when you say scan, I mean, those are the commands from the HBase shell. This is a key, and this is a key. This is a totally in the red is a map. This is a key and a map. Within that, there is a key as well as map again. Because we have the name is a key. See column you have, name is another key. E is a key, row key is another key. So how many you have? Keys, 3 keys. That's how this. Key 1 map 2, key 2 map 3, key 3 value. So if you need to access anything, you have to give the key. Or not only row key, but you say the column family E or D. If you give, then column family D values will come. But if you say not only row key and the column family, but also column, which is name. If you give that, you get the value, Amar. See, this is a logical model. This is internally it is stored like this. So with the 3 keys in HBase, if you have billions of records, it's easy to get the data because it's a faster read. If you understand this, based on the key map. This is 3 nested. So this is the column families, how they are stored. Any questions here? I mean, I just want to, further if I go, I want to make sure you understood this.
Yeah, Nagesh, we are good. We understood.
You're okay, right?
Yeah, I'm okay.
Yeah, you're okay.
Okay. So this is how internally it is stored. This is how you, when you say put, you will do that. I mean, there are different ways of loading the data, reading the data, but I'm giving you the internally how it is stored. So, for example, here, RDBMS, you have the fixed. I mean, I told you, no, this is a flexible data structure. What I meant is, here, ID, name, salary, sex, D number is fixed. And even in this, it is fixed. For example, here, in the, I can insert saying that 101, E column family, qualification. I can add it. It won't. In the table, we are saying only column families, but not the column names. But when you're writing at runtime, you're creating all the columns like this. So each user, each row key will have different attributes. Can be, don't know. Okay. Let me. So this is a, I mean, I just want to store, if that was a confusing, I thought I can show you this key value. So 101, this is a map. And within that, you'll have a pair 1, E, and then name, Amar, salary, sex, the number. And I can have, here I can say qualification. This is all, everything is I'm giving dynamically. Here I can say state for one user, for not all the users. And you don't need to give the data types also. Based on your data, it will understand whether it is a string or a number or whatever is that.
So
See,
this
first in the RDB.
or you're reading the data?
What is that?
No, the structure you're showing us, is it how you put the data into HBase, or this is how you read the data from database?
No, I'll come to that. I mean, this is how you put the data, logical model. So you say the key value and the family name and the value. And of course, there will be other time to live and the version and all, you don't need to worry. But these are the minimum. I'll come to that shell just in a minute. How you store. So in the design time, you don't say what are the columns. Only runtime, you can give that. But if you're converting existing one, there are ways to fix that and all that. We'll come to that later on. But are you, this is what I meant. And when I say that it's a flexible, that means you can user to user, you can change the attributes. You can have many attributes or less attributes. You can have, so nothing is stored. This is a column store. That's the reason.
Okay.
So, I mean, this is more, I just put, okay, key value, map. Key is the row key here first, and then the value is the map. Within that map, you can have pair one or pair two. Within that, you can say E column. This is a key again, E column. This is a map. Within that map, what do you have? Name, salary, sex, and all that. I mean, I just separated it to understand you the key map. Key map 1, map 2, map 3, all that stuff. And I mean, there are different ways you cannot use select. You will say get and all that. We'll come to that. But if you look at in a relation world, what do you say? Select family name, column family, column name from E info. That is the table name where ID is equal to 101. You say that. So what happens? It goes to the ID 101. Go to the family, E family, and the column name. Then it will show you that. There are 3 keys you are passing it. That's what you have to remember. If you pass only 1 key, you get everything. If you just say row key and column family, you get all column family details. But if you say specifically name, you get only that. I mean, this is another example I said. For example, you have your resume. If you want to keep it in the column store, what do? You have first resume, you need to create a ID for that. That will be a row key. You have personal details, name, age, city. And education summary, this is another column family. Undergraduation, master, PhD. Experience summary, first experience, second experience, third experience. So you don't need to do any joins when accessing this data. What happens, these are the 3 column families and 1 table called a resume. And it will have a row key. You can store first experience only. Suppose, for example, he has finished, he got only just recently graduated. Then you don't need to store anything like experience. So if you already experienced, he graduated in 3 years back, then you say 3 years experience. So it is all dynamic, right? The information. So within HBase column store, you can create for each user different attributes. That's what I'm saying. Okay. I mean, till now, we talked about the data model, which is a map of map. And we compared with HDFS and RDBMS. And we are going to go for shell. You want to take a break or you want to continue? I just want to ask you, what is the time now? To you guys, you want to finish it and go and?
We can continue, I think. How long we can take?
Continue, right?
30 minutes or so, then we can take a break.
Yeah.
Okay, sure.
How much time you need, Nagesh?
Maybe 25 minutes or 30 minutes maximum. It depends on the questions.
No, if you have content, you may transmit.
Okay.
If you have content, I think if you have content, take a break because it's a good session. They're paying attentive, I believe.
Okay.
So if you don't have content, that is a different matter. So if you have content, I suggest take a break. If you don't have content more than 30 minutes, you can continue.
Slides, I believe. 4 slides. Want to continue?
Emma, what is
go ahead.
How is it going?
Let's continue.
Okay.
I will continue.
Okay.
Okay.
Same things you can continue.
Okay.
Maybe Sunday.
Yeah. Thank you.
Wrap it up.
Yeah, I know. Everybody wants to go. SDFS in HBase shell command, if you take any Cloudera VM, I think you must have installed it. If you go there and say HBase shell, get into the HBase shell mode. So, I mean, I just gave you SDFS allows for fast writes and scans, but updates are slow. But it's bad for analytics. So you cannot do in HBase aggregations. I mean, why? How you can overcome? I'll come to that. So there is no concept of databases in HBase. Just keep it in mind. So table is a database. You go to HBase shell, and if you list initially, you get nothing. No default database or anything like that. So if you create a table, this is how you create. Create, quotes, table, tab 1 is the table name. And the second one is the column families. You can give multiple column families. Create table 2, CF1, CF2, CF3, and like that. There is no limitation in that. So each table, when you say list, it will be shown tab 1 and tab 2. So table is itself is a database for you. Column families are nothing but tables. Keep that in mind. So what are the commands in HBase shell? There is a put, scan, get, delete. There are only 4 commands in the shell it gives. Put is nothing but insert or update. Both are same. If you say put, if data already exists for that key, then it will update it. Otherwise, it will insert it. Scan is, sorry, it's a typo. All rows. It's a sequential reading. Get is nothing but a random reading. You can give the column or whatever the keys if you give, it will pick up the randomly. Delete is a column only. You cannot delete entire table or entire column family. You have to delete each column manually. This is a high level. Any questions here? This is simple, right?
Yeah.
Yep.
Okay. When you say put, I will say table name. This is a row key 101, and column within that you say the column. When you give the column, you have to give which column family it is associated to, and then the value. The same way. So you have to say put tab 2 101 CF Pinny 2000, tab 2 101 CF2 colon C, the value is 2000. So there are, when you say put, you have the 4 columns. One is the table name, the other is the row key, there is a column and its value. I mean, forget about other versioning and all that. So this is how you can run this.
So the 101 is the row key, right?
Right.
So you cannot provide the values for all column values in the same command?
That's what the last one is the value. The A value is 1000.
Okay. So in the same put,
okay,
you can add more column values there. CF1 column B 2000, everything in one command.
No, you can't do that.
So
you remember,
okay,
when you create HBase, it's a column store. You put only columns. You cannot have 2 columns at a time.
Okay. Yeah, just like in your RDBMS world, right? You say insert values and you give all the column names and then you give all the column values, right?
Right. Similar to that. That is a row insertion. This is a column insertion. So here, tab 2, 101, similar to that. I mean, you can give, for example, in RDBMS, column, E column family. You can give the name. I can type it for you.
So if you want to put one complete record, say employee and department with all the values, then you have to give like 10 or 12, how many number of columns you have, those number of commands.
Yes.
Put.
See here, if you remember, this is the one.
Yeah.
If you need to do this way. So you have to convert this to, let's say in our example, put e-info is our table name, right? First is that, and then row key. Row key can be numeric, so 101. You don't need to be quotes. And then column family. What is that? E column family and name, right? And then you have Harun. That's it. This is only for one column you have done that. So similarly, you can do for the same row key, you can have a different column. Name, what was that? Age, you can say 23, because the same table, same row key, E column family, age 23. And what is the other one? Salary. Salary. And sex, okay. So I don't know whether you're able to see that. I'm sorry. Does it take? I'll remove this. I think this makes sense for you guys. So salary 10,000. Oh, I did that. Age. Let's say sex. Go through it. Male. And D family is the D number. Let's say 11. D name. Because it's a string, I have to marketing. And what else? You have the city. Which way? Does this make sense? When you write to the employee info, this is what we did. For one e-info, the keys, when you load it, you have to do this way. But if you need to do same thing for other row key, then you have to change it to this. You can change name to hurry. Let's give him 20,000. So this is how you put the, when you say put, this is what happens. This is a one row key, this is another row key. But if you repeat this, if you want to update the city, Hyderabad to some Bangalore, you know, what you need to do, just type this and say Bangalore. If you re-enter this, what happens? Only one will be kept. Latest one will be there. This will be gone. So that's how you do update. You're with me on this?
Yep, sure.
Nick?
Yeah.
Did I do something? So assume that marketing Hyderabad. I'm just removing so that you guys. Okay. This I don't have any directly. If you scan this, let's say e-info. So you know how to load, insert the data, update the data now. But you want to scan the data. Scan means all rows. You cannot give, I want one row or like that. But what you can do is scan info. You can say projection, you can do that. You cannot do filtering. So in the scan, you can say columns. I want to get only E family when I read it. I don't want D family. So then you can do that. Or you can say that I want only E name, E age only. You can do that scanning. For all the row keys, you'll get the data when you say scan. But you cannot say, I want to filter it. You can have projection, but not filter. There is no way across here. Okay. This is, I was trying to give a different example. So random reading. So, you know, create, I told you how to do create table with column families. You know how to put the data, how to scan the data. You can give columns or only just family name. I'm not reading anything. If anybody chatting, I'm sorry. Let me know. And the random reading. In the random reading, you can give this way. Get, there is a command called get. You can say the table name and the row key. If you give that, only for that particular row key, you can get the call all column families. Or you can say for this row key, I need just column family name only. So you can get that. You can remove this, I think. For the random reading, this is how you do that. For updating value, you can do this. If you keep the same, if your name is Harun, if I want to make it as Ravi Kumar, then I can do that. Okay. Let me do that here. You know how to scan, you know how to put random reading, you know how to do that. You can say updating the value. You can give the same row key and family name, column name, and the value, different value, then it's overwritten. If you want to delete, you have to delete by column, I told you. You cannot say just family name. You cannot do this. You have to give name or the number, whatever is that. So if you delete for the D column family, if you want to delete this column family, you have to individually, you have to do this. Delete this name, delete DCT, delete whatever is that. If you give that, this entire family data will be deleted, but E will be there. But if you want to delete total row key value for the row, you have to delete all the column families. Then automatically this will be deleted. You cannot do in the RDBMS, you can say delete table name where ID is equal to 101. You can do that, but here you cannot do that. Just keep that in mind. And aggregation also, you cannot do that. So these are the basic commands the HBase shell gives, just to put, scan, get, and delete. That's all. Anything else, you cannot do joins. Remember that. The idea is when you design, you have to design in such a way that database is created as a table in HBase and group all the tables into column families and try to match with one row key. That is the hard part here. When you do inserts, it's easy for it because you know the way it is writing is just the columns only, not rows. And with this, you cannot do aggregations like you select some of the column salaries based on the department. You cannot run this query on this in HBase. And you cannot do the other thing is like you want to increase 10% for each employee, 10% raise. You cannot do that from HBase. These are the limitations. So for that, there is a way you can do that. So we have to use Hive and H integration, HBase integration. So are you so far is okay? HBase shell. What are the commands and how to do that? How it is?
So how do you delete a row key, right? So if you say 101, I want to delete the entire row 01 column.
So you have to delete all the column family columns, all the columns in the row key, one by one.
Wow. Isn't that too much to delete one record? When it's
Yeah, I mean, that is the limitation in HBase shell. I'm not talking about you cannot do that.
Oh, okay.
You cannot do it through shell.
Oh, okay.
So what you can do is, there are many ways.
APIs,
one is
connectors, like
APIs are there.
Okay.
So API is good. You can do API. The other is you can do Hive integration with HBase. So in Hive, what you can do if you want to delete, you can do that, right?
Yeah.
You can overwrite it.
Yes.
Overwrite with without this row key, right?
Yeah.
So that is the one way. The other way is using API. You can do that. So there are workarounds. Not in the shell, you cannot do that. There is a workaround.
Okay.
If you don't have any questions on HBase shell, then we'll go with Hive integration. How it works, we'll see that. I mean, okay.
Yeah, we'll proceed.
What is that? I'm sorry, somebody's saying something?
Narayana was saying we can proceed.
I'm saying we will proceed.
Okay.
Okay.
You're good to go. Yeah.
Okay. So what you can do when you do Hive integration, the way you play in VM is open Hive shell and HBase shell simultaneously. Okay. What you can do is in Hive, when you say show databases, you have seen that what are the databases, default database and other employee database, whatever you created, it will show, right? In that, let's say HBase doesn't have any table right now. What we do is Hive, we go there, create a table, Hive tab 1, K is a key is integer, value is integer. Let's say that. This is a small example I want to give. So when you create that, you have to give HBase storage handler stored by, I mean, you have to say ord dot Apache. I think spelling is wrong, but I'll correct before I send this deck, I'll correct it. Don't worry about that spelling mistakes. Hadoop.hive.hbase.hbase storage handler. So what happens is when you create a Hive table, either the underlying can be SDFS or it can be HBase. If you don't give stored by this HBase handler, then by default it stores on SDFS, right? So with this command, you can give HBase storage handler with, I mean, this is all extras, you can give that. With certain properties, HBase columns mapping, you can map the columns. What do you say? The key is the first one, K integer. And the next one is the V integer is X family, A column. I mean, this is how you can create it. And extra, you can create the HBase table name is equal to HBase table 1. Here you are saying Hive table 1, but in HBase, when you do this, what happens is from Hive, you're creating this table, HBase table in HBase world actually. So HBase shell, you can see this table created. I mean, this would have been good in if you have interactively both, but I'm just explaining you.
No.
Are you with me so far? How you integrate with HBase? There is nothing like Hadoop administrators need to do anything. You need to just go there and give the stored by option. That's all. This is only when you don't have table already in HBase. You try this. You create a table in Hive and automatically all these key values are created with a table in the HBase. And you can load the data in HBase using a put commands, and you can use select commands in Hive to see the data, which is there in HBase, not in Hadoop, I mean HDFS.
So how are the column families internally mapped to Hive from if you create from?
That's what HBase column mapping here, you have to do that. You know, the first is the key, and that's what you said, column key, comma. And the second value would be column family is X, and you're saying this A. So you're giving instruction to the HBase saying that the first one is a key, and the second value, second the column in Hive is, this is a V integer, right? That will be, goes under the X family as a column. So you have to do this Faraday properties, HBase column mapping.
Okay. So if you have
This
say
table property,
column families, right? Like map 1, map 2, map 3, and so you'll have to map each of the column family and column to a column in the Hive, right?
Mm-hmm.
Okay.
I mean, if once you do, I think you will be all be cleared. I mean,
Yeah,
this
sure.
is how, if you know how it is working in RDBMS, how it is working in HBase, then you can do vice versa mapping. This is what I'm taking is, there is no table in HBase, there is no table in Hive, so we are creating it now. But let's say if you already have data in HBase and you want to go do integration, Hive integration, how do you do that? Then you have to say external table here, create external table, Hive, and then you have to map it what the existing HBase handler. So let's go there. So you can load data into HBase, and then once you load the data in HBase, you can do all the batch level operations in Hive. You want to do aggregation, sum of the salary. You cannot do in HBase shell, right? You have to use a API. Instead of that, you can use Hive to aggregate that. I mean, you cannot use window functions and all, right?
Yeah.
So this will help you, Hive and HBase integration. You can use Hive. And the other thing is, I mean, you can use Spark too to do these aggregations. But the advantage with Hive is, if you want to give the end user some control using the browser interface like a Hue on Hive in Cloudera, what you can do is you can integrate this table with Hive, and they can query from Hive or Impala. You know, that's easy. If you want, somebody wants aggregation, I mean, the benefit of this whole thing, if you see online application writing to the HBase, because that is the OLTP application, it is writing to the HBase. But What you can do in HBase is loading the data, random faster writes. You can have a random reads also, but you can also do batch level operations like aggregations, reports, or anything. You can do it from Hive, and that you can give it to the end user on Hue on Hive or Impala on Hive or whatever is that. Then users, without knowing all this get, put, and all this commands, they can run it. They would not know this is running under HBase. They will think that is they can do random queries. They can have a faster write from the OLTP application, and then they can do the batch level aggregation using the Hive on Spark or Hive on MapReduce. This is a solution we built earlier in our project. And people want to do some more faster processing and all that, they can use Spark, right? So this is all the solution for OLTP application. We given HBase, Hive, and Impala using a Hue integration, and as well as Hive and HBase integration. Are you getting the total picture? I mean, I didn't write it, but I'm giving you.
Yeah, sure. That's great. I think we're getting the picture. We can actually start the shell and dig something and start. We will start learning. Everything will be clear. Once we have the basics,
Right.
we understand what HBase is, how it is storing. The next logical step is just to make your hands dirty, get in, start the shell. Just like we did Hive. We created the Hive shell, we created Hive tables, then we integrated with Spark, we put data, we got the data, and we did a lot of Hive sessions. So same thing, I think,
Right.
to get into HBase and start running commands. You have a lot of tutorials as well online, so it will be easier. Yeah, we'll try to see. We'll get probably in the coming week. We'll try to have a session. One of us in the team can explore and present a use case, HBase and Hive kind of a thing.
Right.
Yeah.
Right.
But yeah, this is great. I mean, you need to have the basics. You need to, as you said, uncover. You need to know where to start and how to start. Rest of the things will
Right.
once you start doing it. Yeah.
Okay, this is I believe last slide. People who don't know Impala, the Impala is a what you call, it is a distributed SQL query engine on Cloudera world. So we can aggregate large data sets for the OLAP world. That is good, actually, Impala. So HBase is really good at handling tons of small concurrent transactions, doing OLTP and Hadoop. There is no way you can do OLTP and Hadoop. The only way is taking the help of HBase. Otherwise what happens is, if you don't use OLTP, you will create a lot of small files on Hadoop world. That will be a big issue in the big data world. I mean, just remember this, because some of our clients, when I worked, they were writing to the HBase Hadoop streaming. There are a lot of tons of small files they created that create a production issue. And we have to stop that application altogether unless they convert to the HBase. So these are the practical issues. So the trade-offs is OLTP workloads and HBase. If you look at the HBase on the OLAP workloads, it's not good, because you have to create for everything a new table and keep doing it. So you have to take the best of both worlds. OLTP use HBase, and for OLAP use Impala or Hive, because it's a batch processing. And of course, Kudu is coming up. They're given a trial version in 5.13, I believe. It's a compromise between these two things. Okay, people are using OLTP for HBase and OLAP for the Hive or Impala, but they're not happy. And Kudu came up a different way. They said we can use OLTP in Kudu as well as OLAP. So we didn't have access to Kudu, so we have to go through this whole exercise using HBase as an OLTP source, persistence. And from there, we used Hive to do batch processing. And Impala also, in the same way. When you can do Hive, you can do Impala also. Once you do Impala, people were very happy because you have both, best of both worlds. With that, I think I'm complete. Whatever today topic I thought I discussed. So thank you very much for you guys. If you have any questions, I will take it.
Yeah. So
any comments you?
Yeah, Nagesh. Before coming to comment, I have one question. So, as I said, that HBase is more oriented towards the mimicking the OLTP on Hadoop. So, how do you integrate?
Correct.
How do you integrate this HBase into the OLTP world? Basically, because when you have a Hadoop system or when you have a big data system, the entire big data world, for such matter, is leaning towards the OLAP world, right? Majority of the work is towards OLAP, except for some, online kind of fraud detection or the real-time integrations. So how do you think HBase is integrating into the OLTP world? How do you integrate HBase into the OLTP world in a real-time scenario?
How is sense? I will tell you. One of the customers we have to do. They have already data in RDBMS. It was in Oracle. And what happened is they were having cash accounting system. I cannot give full details, but what I would say is the customer enters from anywhere in the world. Like, for example, Walmart, they take the bank, right? They interact with the China or any other country for their goods. So they do cash transactions or whatever is that. They pay so much and handling that. So during that state, whatever their balance, account balance and all, they want it updated by in under 3 minutes. That is the SLA. When they want to do that, they used Oracle for that. So data is in somewhere in UK. It gets transferred using the Oracle gateways, and it comes to the different system, and they do all this processing. A lot of ETL processing, they do that right now. And after that, the data is getting back to the source system. It was taking like more than an hour, which is not acceptable. Customer was asking, I need to see in 3 minutes all my transactions, how much balance I'm left with my account. So this is like big companies, this has become a problem. So they said, okay, let's take the data using Spark, big data, they processed it. But even then, they are facing the problem of batch processing. They asked, why don't you make it as real-time processing? Real-time processing on what? You have a lot of workloads you get on OLTP. So for that, we suggested on Hadoop, OLTP for the HBase. Data is captured in HBase, and we run Spark processing for all the transformations and all that. And then using Hive on HBase, they were generating the report and gets updated to the target system. So that was happening within 2 minutes, all this. So every half an hour they run that and they send it. And this high, taking the workload as OLTP, but you want a batched work also for the reports for a higher level management, as well as customer has to get updated in some system where it can see his balance.
Mm-hmm. Okay.
So I'll tell you how they do. Hadoop is a cluster of, let's say, I can tell you one scenario. Okay. We had like 300 nodes in Hadoop cluster. What they do is HBase becomes another cluster. They run it, not on the same batch workload. They have a separate cluster for HBase. So in that you can decide, okay, based on the workload, I need only 40 nodes, 100 nodes based on the data. There is no other workload runs on that, only HBase. But it is on HDFS. It should have HDFS, otherwise it cannot run.
Mm-hmm.
Is that answers your question, or I confused you?
No, yeah, I think, yeah, that's clear. We got a sense of it. So the data, online data, whenever the online transaction happens, that directly gets into HBase.
Yes.
Yeah. Okay.
So when writing, he doesn't need to worry where it is writing.
How do you get the data into HBase? What is the pipeline from the OLTP system?
Yeah, you have a Java APIs. There are APIs. What you can do is, whatever you're using the put and all, that you can, using Java APIs, web services, you can use that. They call that the web services, and it will get onto the Hadoop. HBase integration.
Okay, from the Java,
I interchange the words.
You get the data into HBase, right? Using the REST.
Right. Yeah.
Okay. Yeah, got that. And then you have a Spark streaming application that would run the data of HBase, is it?
Yeah, you can. You can see the one way is, if it is like it is not like an online. You don't want to synchronous. If you want asynchronous, then you can write to the Kafka, and from there it go to Spark streaming, would read that and transform it and write it to the HBase. That also can be done.
Yeah, that's it.
So we didn't have that luxury because there was two issues. One is the connectors between Oracle Gateway and Hadoop was very expensive, licensing cost and all that. So the client was not happy with that the price. And the other is Cloudera doesn't support the security point of view. You need to have Kafka secured cluster as well as Spark streaming. You need to have 2.3 some version. It needs to match. All the libraries are not matching. So we couldn't continue with the Spark streaming for that purpose because everything has to be secured. So that was, if you don't have security issue, you can run it. But that is an issue. The other issue is we had issue writing data to the Kafka using Oracle Golden Gateway. It was a licensing cost very high, so we couldn't do that. These are the practical problems when you do that. I'm just sharing my experience.
Yeah, that's great. I think we got the picture. Yeah, that's great, Nagesh. Thank you so much for taking your time. I requested Nagesh because I know he's having the real, he's been working for last 2-3 years with the bank in Charlotte on the big data, and he's been working on the Cloudera cluster with security, and he did a lot of implementations, and we often keep talking and we keep discussing various things at work, what's happening, how things are. So and I requested him. He was very busy with his kids' exams and family traveling. So in spite of that, he took time for us to share his thoughts, his experiences. So thank you so much, Nagesh, and it was very good. We got all the concepts of basically the NoSQL and the HBase, how the data is stored and how we can put it in the real-time world. So yeah, thanks so much, and it was a very nice session. Thank you.
Thank you.
Thank you.
Yeah, team.
Yeah.
Any other
Thank you.
comments for Nagesh?
Thank you. Thank you, Nagesh.
Thank you, Nagesh.
Very good session. Yeah.
Very good session.
Yeah,
Thank
you're
you.
welcome.
It was very good session.
Thanks.
Thank you very much.
Yep.
Okay, guys. Thank you so much, and let's take this forward, and let's see from the team we can take this and work offline and come back with more to present as a follow up to the session, since we have the basics and understanding of the HBase world. Yeah, we can take up and take it forward.
Yep. If you can take from RDBMS, from Hive or anything, MySQL, and try to do the same thing in HBase, then you'll be more clear all the concepts, how it is working.
Yeah, sure. Yeah.
Okay.
So, Nagesh,
Yep.
just one last question. So I didn't get that Cloudera supporting the security. Can you just throw some light? I think most of the people who use HDFS are mostly tagged to Cloudera VMs only, right? So how that is different from this?
Yeah, no, the security, what I said is different for the Spark streaming.
Okay.
It's not about Shiva.
Compatibility?
Talking more about his actual work experience at the client.
Okay.
No, I mean, I told Spark streaming here when we run in just a virtual machine, you don't have a problem of what is that, security, Hive and as well as SDFS side, right? You don't have anything. What is that? Key tabs and all that stuff. Kerberos. I mean, I'm drawing the blank. Kerberos is a security for HDFS, right? If you're really in a bank or some financial companies, the security is the foremost important. So when you run Hive or SDFS or Spark, I mean, that key tab in Kerberos you for doing anything. So when we run as a batch, there is not much key tabs. Kerberos will give you a ticket. It will last for 24 hours and it will regenerate that. When you go to Spark streaming, it is like a 24/7, the job runs, right?
Right.
So for that, your key tab or whatever security, if it runs out of after 1 week, then you have to regenerate. That Spark will take care. But the problem is the compatibility reading the data between Spark streaming as well as to Kafka, like a publisher subscriber. When you subscribe to the Kafka, then you need to read that. So then there it will exchange the tickets saying that I'm so-and-so, I need this. So there it was denying it. Connection is getting denied because of incompatibilities with libraries.
Okay.
So that they said they will support first in Spark 2.3. So with that, we couldn't do that. I mean, companies are very strict on the security. That's what I was saying.
Oh, okay. Thanks, Nagesh. Yeah.
Yeah.
Okay. All right, guys. Any other questions, comments?
Okay, if no comments, thank you very much for your time. And
Okay.
I know this is a little bit deep into the concepts, but it takes time. But unless you do this, I don't think we can grasp all the concepts.
Okay.
That's all. Okay.
Yep, sure, Nagesh. Thank you so much. That was a great session.
Yeah.
Thank you, team. You guys can go ahead and explore more. And then from next week, we will have only one session, the Saturday and Sunday, and then we can collaborate and come up with the agenda each week based on the people who are interested to the presentations, both on big data and ML, AI, whatever topics you guys choose. And we will run these sessions for some more time, only one day a week from the next week. Srini will update the timings and the day, and then we can collaborate more. Okay? Yeah. Thank you and have a great weekend. And thanks, Nagesh, again. We'll catch up sometime after next week.
Sure. Thank you.
Thank
Bye.
you.
Thank you, guys. Have a good day. Bye.